So in this small video, I'll try to introduce you a little bit how to get started on MATLAB. So I hope you have installed this math program so that you can try it out yourself a little bit afterwards. So let's see how it goes.
So this is what it will look like when you open up MATLAB for the first time. And the first thing we'll always begin with is we go up here in the left corner and we'll choose a new live script. Then we'll get another window. It looks like this, and we don't need the lower window here, so we can click on this one and pull it down somewhat. And maybe even zoom in a little bit like this. So then we can start to do some simple calculations, and we can, for instance, we can try to add a few numbers, 3 plus 4, and then we can try to run this small section. So here, run section with the mouse, and then on the right we will see the result that the answer equals 7. I can try a few more calculations. I can calculate, for instance, a cosine value, and it's just cosine, and then, for instance, cosine of 1.2. So also we note that I use a point for a decimal separator. So if I want to calculate this result, now I go up and run section again, and I get the result that it's 0.3625. I can try to calculate sine of, let's say, pi half, and pi on MATLAB is just pi, and then I divide by 2. So like this, I can calculate this value, and of course I get here that the answer is 1. I want to mention also that I can calculate, of course, a logarithm value, ln of something, but here using the natural logarithm function on MATLAB, this is called log. This is the American tradition. That log is what we in Europe call the ln function. So for instance, log of 3.4, I can calculate. I press run section and it's 1.2. I should maybe also mention that if I want to calculate a square root, the code is sqrt. So square root 16 can be calculated, and I will show you a small detail. If I let the mouse rest on the run section part, you can see that then we get the shortcut that I can also use Control Enter instead. So that is faster, and calculate here the result will be 4. Finally, if I want to calculate e of something using the Euler number on MATLAB, this is exp, and you can see when I type this, I get several possibilities, several options here from MATLAB suggestions what I might mean. But here I just want to calculate e of, let's say, 3.6, and this will become 36 point something. Okay, I think I'll just erase all this. So I delete that. I can also go here and right click, and I can clear all output, so I can start from scratch. So then I think I'll start doing a little bit with a very simple function. F of x equals x squared. So let's just see what comes up when this is the input, and then I'll get an error message here from MATLAB that MATLAB cannot recognize the variable x. So this is because when I want to deal with variables, I always need to tell that now x is a symbolic variables, and this is done with the code syms. So syms x means that now x is recognized as a symbolic variable. And if I now run this part again, I'll see that now MATLAB recognizes this function. It's fx equals to x squared. I could define another function, maybe using the function I already had. So I could multiply this function by 2. So 2 times f of x, and then maybe subtract 4. And I can calculate what will be the outcome of this one, and I get that expression here. I can overwrite this function by writing another function g of x. In this case, I think I'll use the function 2 times x, 2x plus 5. But here I made on purpose another small mistake, so you can see that I'll get another typical error message, invalid expression, check for missing multiplication operator, because I forgot that MATLAB will not understand 2x. I have to be explicit with the multiplication sign. And MATLAB also suggests here, did you mean 2 times x plus 5? I can just press fix here, and then I have something that is understandable for MATLAB. So now I have these two functions, f of x and g of x, in my code already. Now I want to plot these two graphs in the same coordinate system, and that command is fplot. And of course, all these commands you can see in my MATLAB notes also. So then in brackets, I need here the square brackets, and then I write f of x comma g of x. I want these two functions in the same coordinate system. And here we have the graph of these two functions. I realize that there are two intersection points, so maybe I could be interested in calculating what are the coordinates for these intersection points. So I need to solve the equation f of x equals g of x. So this is using the solve command, and then f of x equal to, and here I need, when I solve an equation, I need two equation signs. So I can let MATLAB solve this equation for me, and I will hopefully get two solutions. You see them here, 1 minus square root 6 and square root 6 plus 1. If I want to calculate what are the y coordinates, I can of course substitute this answer into the function, for instance f of x, and then I'll get the two corresponding y coordinates. In this case, maybe I want to approximate these values, so that's done by the double command. It's double precision, it's called. It means it will approximate the results. So if I double now what is now the latest answer, I'll get these two y coordinates approximated. And you see them here, 2.1 and 11.899. What can be an idea when we solve an equation, quite often we need that solution to something else. So if I up here in the line where I solve the equation, I could give the solution a name, for instance x0. So x0 equals to the solution here. And if I run this, I'll get two x0 values. So I think I'll just get rid of these two commands. And then here you see that now my two solutions, they are called x0. If I want to extract one of them, they are now automatically by MATLAB, they are called x01 and x02. So for instance, x02 would be the second answer I get here. So you see this is square root 6 plus 1. So I can always extract one of my solutions if there are more solutions. I think I'll show you something else now also regarding this. I will define a new function for f of x. So this should be a fourth order polynomial, x to the power 4 minus x to the power 2. And I'll just see if I type this correctly. So I run this part and I see over here to my right, this is what I meant. So now I have a new set of functions f and g. I want to plot these two graphs in the new coordinate system. So this was the fplot command. And then in the square brackets, I need f and g. And in fact, I don't need to write f of x and g of x. It's okay to write just f comma g. And here we see this graph. In this case, I think I want to adjust the y-axis a little bit, because it seems like the g function is almost horizontal in this plot. So this can be done with the ylim command. What are the y limits? So also here I need the square brackets, and in this case I think I'll choose the y coordinates or coordinate axis to be from -1 to 20. So this is done in this way, and then I just repeat everything, and then the graph will look a little bit better. You see it here. and I realize there are still two intersections. So now I want to see if I can find these coordinates. So I want to solve the equation where I put f and g equal. So two equation signs. Also, in this case, I don't need to write f of x and g of x. It's okay to write just f equals g. And then in this case, I'll see that there are in fact 4 solutions, because there are some complex roots also. I think I want to double this result or approximate this result. So I will double the last answer. So you'll see the 4 roots I get here will look like this. And you see the 2 mentioned here first, they are complex numbers. There's something with an I popping up, and maybe you don't know about complex numbers right now, but we will get to that very soon in our course. But here I can see something where there is only 0 multiplied into I, so it means the last 2 values here, they are the 2 solutions I will read as x coordinates to the 2 intersection points. So if I want to see only get solutions in the real numbers, it means that I should define x to be a real variable. So if I go up here and change so that I define x to be a symbolic variable but also a real number, then it means I will automatically neglect all the complex solutions. So then I see only the 2 solutions that I can also see from the graph. Whoops, here they are. So this is something that could be useful to do when we don't want to do calculations within the complex numbers. We simply add real up here when we define the symbolic variable. So this is what you should also remember all the time, to define the symbolic variables. Also, if you do something with other constants and so on, they could be a and b, for instance, they are now defined. So now if I do calculations here, I'm allowed to add in an a. It will now just be some unknown constant or variable, so that now I'm doing functions with f of x, a equals x squared. And of course, MATLAB is not able to plot a graph right now because it doesn't know what the a is. But I think this is the most important things, so that you can actually now start a little bit yourself, trying out different things. And remember, all the necessary codes you can find in the PDF file on It's Learning. So good luck with that, and I'll see you at the lectures.